In this Grasshopper tutorial, I'm going to demonstrate how we can very simply create this three-dimensional fractal in Grasshopper using the Python node. To begin with, let's create an input for this function, which is simply going to be a triangular pyramid. So we'll drop a polygon node down on the canvas, and we'll set the number of segments to be 3. And in this way, we'll create a triangle. We can turn that into a surface by using the boundary surface node. And then we can turn this surface into a pyramid by simply using point extrude or extrude point. And this will be the base, and the point can be defined using the construct point node. The construct point node, and we'll give it an input and the z coordinate between 0 and 10. And as you can see, this now creates a pyramid. And this function will work with pyramids of any shape, so have fun experimenting with this input. Now, we have created a BREP, or a polysurface, and we would prefer to have a mesh for simplicity, as you'll understand once we get into Python. So we can simply say mesh BREP to turn this BREP into a mesh. But you'll notice that this output mesh has 15 vertices, indicated by the V15. And we really only need 1, 2, 3, 4 vertices. So we can use the combine and clean node right here. And as you can see, this takes in a mesh with 15 vertices, gets rid of redundant information, and outputs a mesh with 4 vertices. This will be very useful, and you'll understand why in a moment in our Python script. So let's drop a Python node on the canvas, right-click on this input, and we'll set this to mesh for clarity, and this will be our recursive depth. And we can also set the type hint here to be mesh to specify that we only want mesh inputs, and this type hint will be an integer because the recursive depth must be an integer. We'll begin with a recursive depth of 2, and you can play with this number once we create our function. If we hook up a panel to the output, then all our error messages will display here, and also our print statements, and another panel to the output of this A node, which we can rename to Fractal. This will be our Fractal output, just so we can visualize the data output. So now we're ready to open scripting. So start scripting. We'll open our editor, delete all this unnecessary information to get rid of noise. This line is importing a library and aliasing it as rs, and we can access any function in this library just by typing rs dot, and here you can see there's a long list of functions that we now have access to. So now in just 8 lines of code, we'll have a beautiful fractal. So the first thing we're going to want to do is initialize our output to be a list containing one mesh, which is our input mesh. And now for I in range depth, we're going to repeat this process. We will create a list, and this is a temporary list, and we'll leave it blank for now, and then we'll iterate through each mesh in this list of meshes. So for mesh, except that variable name is already used, so we'll just call this pyr as an abbreviation for pyramid. So for each pyramid in Fractal, which is now a list of pyramids, we're going to want to extract all the points of this pyramid and scale the pyramid about each of those points. So to get each point of a mesh, we'll use the function rs.meshVertices, and this function takes in a mesh, which is pyramid, and it'll output a list of points. Now you understand why we only wanted to have 4 points and we didn't want to have extra points. So now for point in, this is a list of points, so we'll call this points. For point in points, and for consistency's sake, let's just capitalize point. what we're going to want to do is say new pyramid equals rs dot scale object. We're just going to be scaling this original pyramid around this point. And as you can see, the parameters for this function are defined here under the help tab, which is very convenient. So the third input of the scale function would be a scale, which turns out to be a list of numbers, which are the scale in the x, y, and z dimensions. So we'll just type 0.5, 0.5, 0.5, and then the very last input is going to be whether or not we want to copy the original pyramid, and we do, so we'll just type true. Now we can simply add this new pyramid into our temporary list. So we'll say temp plus equals, and we'll toss this new pyramid in a list. So now we're concatenating this new list onto the end of our temporary list. And then after this whole process is done, what we're going to do is just set fractal equal to temp. And now if I press test, you can see that everything was successful, but we're going to have to preview all of this off in order to visualize our result. Now, careful not to crash your computer by cranking up this value too high, because the number of faces that are created exponentially increases as this number slider increases. So now enjoy the beautiful three-dimensional fractal that you just made. And if you enjoyed this video, like and subscribe for more content. Thank you for watching and have a wonderful day.